Okay, this section of section E on page 107, we're going to talk about how we multiply a binomial with another binomial. So in the last examples on page 106, we were multiplying a monomial, one term, with a binomial. So this time we've got a two-term factor multiplying with another two-term factor. Again, if we use a pictorial model and we represent x plus 2 as this side of a rectangle, and we represent x plus 5 this side of a rectangle. Of course, we know if we multiply length times width, we get area. And representing that in a picture format, we can split this rectangle up into 4 sections, which I've already done. And we can find the area of each little individual section. So x times x gives you the area of this guy right here, which is x squared. X times 2 gives you, this guy is x, of course, and he's 5, and he's 2, and he's x. Gives you an area of this little section of 2x. 5 times x gives you this one, and 5 times 2 gives you this guy. And if we add the area of all 4 of these smaller rectangles up, we get the area of the largest rectangle. So we're adding x squared plus 5x plus 2x plus 10. Simplify our like terms, which are these guys. And we end up with x squared plus 7x plus 10 written in standard form with regard to the variable x. So here's our problem. This is what we started with. We did it picture-wise, but if we wanted to skip the picture, we would know that our answer, therefore, there's my therefore, our answer to this multiplication problem is going to end up being x squared plus 7x plus 10. And we'll talk about what the mathematical procedure is to get that answer without actually having to draw a picture. So we are actually going to use the distributive property 2 times to multiply these binomials together. I will tell you up front, there's a couple different ways to do this type of multiplication, and it might be that when I check with Miss Jett, she has me show you the other way as well. But right now, the way that we're going to learn this is we are going to take each one of these first terms and we are going to distribute it to this second factor. So that means we're going to take a squared and multiply it times a plus 2, which is the second factor. That takes care of that. And we are going to add to that 1 times a plus 2. So this is really, we could go up and represent this with our picture like we did the example right above this, but without drawing a picture, we're going to take each term of the first factor and multiply it times the second factor. So when we, that's a squared there. When we go ahead and distribute, a squared times a to the first is a cubed plus 2a squared. And then I'm going to distribute this guy, so I've already distributed him, plus 1a plus 2. And now I need to collect my like terms and write it in standard order. Well, I don't have any like terms. I've got a to the third, to the second, to the first, and a constant. So I am done, fini, with that problem. It's as simplified as it can get. Let me skip B for right now and come down and do C. So if you look at what this is asking you to do, it's saying take n minus 3 and multiply it times itself. Take n minus 3 as a factor 2 times. Now it looks like the example that we did in A, and we are going to multiply n minus 3 times this second factor, double distribution. So n, the first one, times n minus 3, minus, take that sign right there, 3 times n minus 3. Now when we do the distribution, we get n squared minus 3n. I'm distributing minus 3n plus 9. When we collect our like terms, those guys are alike. They do not cancel each other out. They get more negative. So we have n squared minus 6n plus 9. That's the answer to this problem. I want to point out that the common mistake, and that you might just look at this and say, well, okay, n minus 3 squared, I'll square the n and get n squared. I'll square the minus 3 and get positive 9. That's one common mistake. Second common mistake is I'll square the n, and then I'll leave the 3 negative, leave the negative sign, square it, and get a minus 9. Both of those are incorrect. This is the correct answer. So there are no shortcuts to this process for right now. This is the process you will use to work B and D. D is much like C, and B follows the same pattern as A. So you guys work those, and then we'll talk about them when we get back together in class and see how you do. Thanks.